Our final lesson in Chapter 2 is 2.7, Inverse Functions. In this lesson, we'll calculate inverses algebraically and we'll graph. We're actually not going to do the horizontal line test, so we can cross that objective off. Let's take a look at what it means to have an inverse function. When ordered pairs interchange the first and the second coordinates, you've created the inverse. Inverse functions are written as f with a -1 after it of x. That would mean it's the inverse for f of x. So it's just kind of a notation thing. For the graph of an inverse function, by definition, graphs of inverses are the reflection over the line y equals x. So if you think about what that looks like on a coordinate system, x and y would be the same on that line. If x is 0, y is 0. If x is 1, y is 1, and so on. So that reflecting line just kind of diagonally cuts your graph in half. And the inverse would be the reflection of that line in one direction or the other. Let's go ahead and graph f of x equals 2x minus 3. Then we'll graph the inverse. The first thing we'll do is we'll sketch that reflecting line. So we're going to sketch the line y equals x. And we'll use a dashed line to make that happen, since that isn't our actual equation. If we're going to sketch y equals x, remember that'll go right through 0, 0, 1, 1, 2, 2, 3, 3, and so on. That's when x and y have the same amount, or same value. In the other direction, -1, -1, -2, -2, -3, -3, and so on. We'll go all the way through our graph. Using those points, let's draw a dashed symmetry line at y equals x. I'll label that. Next, let's graph the equation f of x equals 2x minus 3. To sketch that graph, we're just going to make a table. And the reason we're making a table is that it'll quickly help us calculate or graph the inverse. When we make a table, I'm just going to pick as many points as I can that fit on my coordinate system. Now 2x minus 3 is linear, so it should just be a plain straight line when we're done. If I plug in numbers like 0, I get 2 times 0 minus 3. We have a y-intercept of -3. If I go to the right, positive 1, 2 times 1 minus 3 would be -1. Positive 2 times 2 is 4, minus 3 is positive 1. 3 times 2 is 6, minus 3 is 3. 4 times 2 is 8, minus 3 is 5, and that's as high as my graph goes. So then if I go in the other direction, -1, -2 minus 1 would be -5 in the other direction. Plotting those sets of points, we have 0, -3. And now notice if we go to 1, we're down to -1. 2, we're up to 1. 3, 3, we're right on that reflecting line. 4, positive 5. You can tell the slope is positive 2. If we go to the left, -1, we're all the way down to -5. Go ahead and draw a line through those points, and that's our original function. Be sure to go from edge to edge. Now as we sketch our inverse, we'll use our table to help us. And here's how it works. We're just going to interchange our input and output values like the definition stated. So, or our coordinates, I suppose I could say it that way too. Instead of 0, -3, we're just going to have -3, 0. 1, -1 goes to -1, 1. So you're just switching the order of the coordinates. Plot those points and let's see if we can tell that it's reflecting over that boundary line that we drew initially. -3, 0, -1, 1, 1, 2, 3, 3. So now we're intersecting right on that line again. 5 up, 4, and then -5 down, -1. If we connect these points, well, see if I can get those to connect here. There we go. You could take the red line and reflect it over that black dashed line, and it should match up on the blue. That's the graph for the inverse function. To determine the inverse algebraically, we'll calculate it. So the first thing we're going to do is take our original function, f of x equals 2x minus 3. And instead of f of x, we're going to plug in y. So instead of f of x, we'll just have y equals 2x plus 3, or excuse me, minus 3. The second thing we'll do is we'll switch x and y, which is easier to do it this way than it is to switch with f of x. So we're just going to switch the order of x and y, and that's the definition of inverse, switching those coordinates. Instead of y equals, we'll have x equals, and then 2y minus 3. The third thing we need to do now is solve for y. So just get y by itself, and make sure to simplify if needed. And I'll add that over here on the right. So this is my step 3 still. X equals 2y minus 3. To get y by itself, we'll add 3 first. X plus 3, they're not like terms, so we just leave it as x plus 3. Get y by itself now, divide both sides by 2. Now this is going to be the equation of a line, so we want to know what our slope and y-intercept are. That means we're going to split the fraction. Technically, the number in front of x is 1, so that would be 1/2 x for our slope. And then 3 over 2, 3/2 x is our y-intercept. Last but not least, we're going to go back to our inverse notation. If you remember from the top, we have to use f inverse of x as our inverse equation. So f inverse of x equals 1/2 x plus 3/2. That's determining the equation algebraically. And if you look at your graph, it says 3/2 is the y-intercept, and that looks pretty close to where our graph crosses the y-axis. So we have a match. That's it for lesson 2.7.